You've seen the headlines, right? Study shows a link between X and Y, and it's all based on this one single number. Well, that number is usually the correlation coefficient. And let me tell you, it's powerful, it's persuasive, and it can be incredibly deceptive. So today, we're going to pull back the curtain on this little number R to see how it can both enlighten us and, honestly, totally lead us astray. And that really is the big question, isn't it? Can one number, just one, actually give you the full picture? I think you can guess the answer. But by the end of this, you're going to see exactly why a single number is almost never the whole story. So let's officially meet our main character, the correlation coefficient. Most people just call it R. It's a simple little statistic that tries to boil a really complex relationship down to just one value. But I want you to burn one word into your brain right now: linear. That word is the key. Seriously, it unlocks this entire thing. Okay, so the scale itself is pretty simple. +1 means a perfect positive correlation. As one thing goes up, the other goes up right along with it, in perfect sync. -1 is the opposite. As one goes up, the other goes down, perfectly. And 0, well, 0 means no linear relationship at all. Sounds simple enough, right? But that simplicity, that's the trap. That's where the deception starts. And that brings us right to our first and probably the biggest myth we need to bust: the linearity trap. This is the idea that a high correlation number, something close to 1, automatically means you've got a strong, clean, predictable relationship. Yeah, about that. To show you what I mean, let's play a little game. I've got 4 different sets of data here. And here's the twist. If you just look at their summary statistics, the basic numbers, they look pretty much the same. Same average, same variance, and, you guessed it, the same correlation. Look at this. For all 4 data sets, the correlation is about 0.82. That's a pretty strong positive relationship. So you're probably picturing a nice, clean line of dots, right? All trending neatly upwards. But let's see what's really going on behind that number. And bam! Here they are. Look at this. Only the first one even remotely looks like what we expected. The second one is a perfect curve. The third is a straight line, but its correlation is completely hijacked by one single outlier. And the fourth? It's just a bunch of dots in a line, with one point way off in the distance creating the entire relationship. 4 totally different stories, all hidden behind the exact same number. So here's the absolute #1 thing to remember. R is a specialist. It has exactly one job: to tell you how well your data hugs a straight line. It is completely, utterly blind to any other kind of pattern. Curves, clusters, it sees none of it. And just to really hammer this point home, get a load of this: a perfect circle and a perfect parabola. I mean, you can't get a clearer, stronger relationship between X and Y than these beautiful shapes. But guess what their correlation coefficient is? 0. A big, fat 0. The number tells you nothing to see here, while your eyes are telling you there's a perfect, undeniable pattern. Crazy, right? Okay, so let's move on to our second myth, because it gets even sneakier. Even when a relationship seems like it might be linear, the data can be hiding all sorts of secrets that R will never tell you about. This quote right here, it says it all. A single data point, what we call an outlier, if it's in just the right or wrong spot, can bend that final number to its will. It can literally invent a correlation that doesn't exist or completely erase one that does. I mean, just look at these 2 graphs. On the left, you've got a blob of points with basically 0 correlation. But you drop one little point up in the top right corner, and suddenly R is 0.90, a super strong relationship created out of thin air. And on the right, you have a near-perfect vertical line. But one outlier yanks the correlation all the way down to pretty much 0. One single point can tell a completely false story. But wait, it's not just these lone wolf data points you have to watch out for. There's another common trap, another hidden story that R is clueless about. So, you look at the graph on the left, and what do you see? Nothing, right? Just a random cloud of data, no pattern. But what if those points actually belong to 2 totally different groups? Look what happens on the right when we give them colors. All of a sudden, 2 distinct clusters pop out. This is called stratification, and it's another bombshell that the single correlation number completely misses. Which brings us to the grand finale, the third and maybe the most dangerous myth of all. It's a phrase you've definitely heard before, but I'm telling you, it's the single most important rule in all of statistics. Say it with me: correlation does not imply causation. Just because two things move together, it absolutely positively does not mean that one is causing the other. This is the trap that everyone, from journalists to scientists, can fall into if they're not careful. Just think about these classic examples. Ice cream sales are highly correlated with shark attacks. Does that mean your pint of Rocky Road is sending out some kind of bat signal to sharks? Of course not. The number of firefighters at a scene is correlated with the amount of damage done. So do firefighters cause damage? No. Bigger fires just need more firefighters and sadly cause more damage. And my favorite, as global temperatures have gone up, the number of pirates on the high seas has gone down. I don't think anyone believes climate change is our best weapon against piracy. So what's the real culprit here? In almost all of these cases, there's a hidden third factor, a lurking variable that's pulling the strings on both things. For ice cream and sharks, that factor is summer. Hot weather makes people eat ice cream, and it makes them go swimming. That's the real driver. So after all this, you might be thinking, well, is this correlation coefficient thing totally useless? And the answer is no, not at all. We just have to be smart about how we use it. It's a fantastic tool, but it is not the final truth. Here's the absolute best way to think about it. The R value is the headline. It's punchy, it grabs your attention, and it gives you a quick summary. But you never read just a headline and assume you know everything about a news story, right? Of course not. The scatter plot, the actual graph of the data, that's the full story. It's where you find the context, the nuance, and what's really going on. So, here's your new toolkit. It's a simple, 3-step plan for thinking critically. First, notice the R value. Acknowledge the headline. Step 2, and this is the most important, always demand to see the scatter plot. You have to see the full story. And third, put on your detective hat and investigate the context. Hunt for those outliers, look for hidden groups, and always ask, could there be a third factor at play here? Because that single number should be the start of your curiosity, not the end of it. So the next time you see a headline or a study or a post that's screaming about a new correlation, I want you to remember this. The first question you ask shouldn't be, how high is the number? It should be, can I see the data? Ask to see the full story.